Okay, here it is, November 30th, or sorry, November 23rd, wishing away time. And I think this will be my last video for the course, unless something else comes up that I need to communicate via video with. And hopefully you saw my email and the assignment. Well, it's assignment in parentheses that I put up on Brightspace. Basically, turn in whatever problems from these last 5 videos in some kind of nice format, especially ones that you have struggles with that I can mark up. And then on Wednesday, which is the 25th, we'll have a Zoom class, and I'll present some subset of the problems, as many as I can get through, and with solutions, or we'll work them out together as a group. So and hopefully that helps. And like I said before, if you've done any of these and you want me to look at it, just email them to me as a PDF. I can mark it up and send it back. Okay, so going backwards, now we're all the way back to chapter 1, which was about linear independence and linear transformations. So my first question is, so we're going to let A be the matrix 0, 1, 1, 0. We're going to define a linear transformation Tx to be Ax, and T takes R2 onto or into R2. So you're to describe geometrically what T does to vectors in R2. That's part 1. And then is T 1 to 1 onto? Prove or disprove this. There's some super strong theorems from chapter 1. I think theorem 12 is in there. That gives you a way to show 1-to-1 and onto-ness. So 2, we'll take the same idea with a non-square matrix. So we're going to let A be 1, minus 4, 8, 1, 0, 2, minus 1, 3, 0, 0, 0, 1. Okay. And define, again, a linear transformation, Tx equals Ax. And question 1, T takes R what to R what? Right? And then is T onto? Is it 1-to-1? Prove or disprove? Okay. That was question 2. Question 3 is one that I really like. Suppose we have two vectors v1 and v2 in Rn, and they are given to be linearly independent, and you're to show that v1 comma v1 plus 2 plus v2, that this set of vectors is linearly independent. In Rn. Okay. This definitely, these last two problems, or all of these actually, are definitely the kinds of things I ask on oral exams because they're quick if you know what you're doing. And you understand what linear independence is and how these linear transformations work. Okay, so the fourth and final question. This comes from the book. It's at the end of chapter 1, the supplementary exercises. Problem 19. Let me bring it up just to make sure I got the numbering right. Yeah, it's this guy. Suppose V1, V2, and V3 are distinct points on one line in R3. The line need not pass through the origin. That's important. Show that the set is linearly dependent. Another good question. Okay. So that's all I got. This is my last video and my last day in Maui. So I'll be back San Francisco tomorrow. And yeah, it's going to be freezing, I bet. Anyways, enjoy, have fun, do some of these problems, and I will see you on Wednesday if I don't see you Monday night in office hours.